Hello, ladies and gentlemen. Today we're going to talk about Roman numeral naming, the stock system. So this set applies to the transition metals, the D block. In order to name those D block transition metals, we have to use these Roman numerals. And the reason is that transition metals can form more than one ion. So sometimes there'll be a +1 charge, sometimes there'll be a +2. It varies depending on what they are matched with. The Roman numeral actually identifies the charge of the cation, and they still follow the same binary rules. For our Roman numerals, that just a reminder is that the 1 is 1 I, 2 is 2 I's, 3 is 3 I's, 4 is IV, 5 is V, and 6 is VI. Generally, they don't go past that. So when a transition metal forms an ion, it is named the element name, and then in parentheses, we write the charge in Roman numerals, and then the word ion if it's single. So for our first example, we have Fe plus 2. So we have iron, and then we're going to use our parentheses to tell its charge is 2. So we use a Roman numeral 2, and then we're going to write the word ion. Iron can also form a +3 ion. So we write iron with a 3 in the parentheses and the word ion if we're just naming that single ion. So here are some examples of writing the transition metal formulas. So we need to go from the name to the ions and then cross them down and end up with our formula. Our first example is copper 2 chloride. So we have copper, its charge is inside of the parentheses, so it's +2. And then we have chloride, which is just Cl. Its charge is -1. Okay? I'm going to cross those down, and my compound is going to be CuCl2. Next, we have lead 3 nitrate. So I have Pb for the lead. Its charge is the +3. Nitride is from the periodic table because it ends in the IDE. So it's just nitrogen, and its charge is -3. Those are the same. So when I cross them down, they cancel out, and we get PBN. Our next example is lead 4 oxide. So again, we have that lead. Its charge is +4 according to the parentheses. Then we have oxygen, whose charge is -2. When I cross those down, notice that those are both multiples of 2, so they can be simplified. So I have Pb and then O2. Next, we have titanium 3 carbide. Remember, the ending is important because if it ends in IDE, it's usually on the periodic table. So we have titanium, whose charge is +3, and then carbon, whose charge is -4. I cross those down, and my compound is Ti4C3. All of these on the right side are actually using polyatomic ions. If you want to stop, get your polyatomic ion worksheet out so that you have those to go off of. It might help you recognize them. So our next one is mercury, which is symbolized by Hg. It's telling us that our charge is +2 because of the parentheses. Then we have OH for hydroxide, and its charge is -1. When I cross those down, I end up with Hg, parentheses OH2. Next, we have silver nitrate. Silver is Ag. According to this, its charge is +1. Nitrate is from our polyatomic ion list, and it is an O3, charge of -1. Cross those down, I get Ag and O3. Next, we have zinc carbonate. So we start with zinc with a charge of +2. And then we have carbonate, again, ending in ATE. So we automatically know it's on the polyatomic ion list. Carbonate is CO3, and its charge is -2. Those can simplify when I cross them down. So it's just ZnCO3. For our last example on this page, we have titanium 4 sulfate. We have titanium, charge is +4. Then we have sulfate, which is SO4, its charge is -2. When we cross these down, notice again, those are both multiples of 2, so they can be simplified. So I have Ti, parenthesis, SO4, 2. Okay. Moving on, we have writing the transition metal, same page. Moving on, we have writing formulas from the transition metal words. So we cross the charges back up. They go opposite ways, from the anion to the cation and from the cation to the anion. We verify the charges, looking for if things were simplified or not. Correct changes and identify the charge of the cation. So starting off, we have copper and chlorine. First, I want to take and cross up my charges. So this is telling me that copper is +2, chlorine is -1. I need to check my anion. So when I look on the periodic table, chlorine is actually in that right column for it to be -1. So those are correct. So I know that this is correct. So when I write the words out, it's going to be copper, parentheses, 2, chloride. Okay. It's a lot to remember as we go through these. In the next example, I have cobalt iodide. So I'm going to cross the charges up. It's telling me that my cobalt is +2. My iodine is -1. Check that on the periodic table. Is iodine actually -1? Yes, it is. So when I write it, I'm going to be cobalt 2 iodide. Okay. Next up, we have copper and oxygen. So I'm going to cross those charges up. It's telling me that copper has a charge of +1. Oxygen has a charge of -2. Check this anion. Does oxygen actually have a charge of -2 from the periodic table? Yes, it does. So when I write my words, it's going to be copper 1 oxide. Next, we have iron and sulfur. Cross those charges up. Fe +3, S -2. Does sulfur, if I look on the periodic table, actually have a charge of -2? Yes, it does, because it's in that group 16 or 6A. So that's correct. So that means this charge is correct. When I write it, I'm going to write iron 3 sulfide. Okay. On our next page, continuing on, we have mercury and oxygen. When I cross up the charges, it tells me that mercury is +1. Tells me that oxygen is -1. When I go to check this on the periodic table, oxygen, that's not correct. So it's actually -2. So then, because this was incorrect, you need to multiply by the same multiple for your cation. So if I went from -1 to -2, I multiplied by 2 here. I need to multiply this by 2. So my charge is actually +2. When I go to write out my name now, I'm going to write mercury, parentheses, 2, oxide. Okay. Next, we have zinc and sulfur. I'm going to cross up the charges. It tells me that zinc is +1, sulfur is -1. When I go to check this, sulfur is not -1. It should be -2. So how did I divide that? And you'll notice that it's a multiplier of 2. So then here I have to multiply by 2. So my charge on zinc is actually +2. When I write it, I'm going to write zinc, parentheses, 2, sulfide. Okay. Next, I have iron and nitrogen. Cross up the charges. Iron, it tells me, is +1. Nitrogen, it tells me, is -1. I check this nitrogen, and I know that's not correct. Nitrogen actually has a charge of -3. So in order to get from -1 to -3, we would multiply by 3. So I'm going to multiply this front one by 3. So my iron charge is actually +3. When I write my compound out, I'm going to have iron in parentheses a 3 and then nitride. Last one on this page, titanium and carbon. When I cross them up, titanium is a +1, carbon is a -1. Check the carbon, that is incorrect. Carbon should be -4. So I know that this has to be +4. Go to write out the words, and it's titanium 4 carbide. Okay. Last 3 examples, we have tin and sulfur. First, I'm going to cross them up. This is telling me that tin is +2, sulfur is -1. Check my negative ion. Sulfur should actually be -2. So I have to multiply this positive by 2 to get a charge of +4. When I write it out, it's going to be 10 4 sulfide. Okay. Next, I have lead and sulfur. Cross them up, and I get Pb as +2, sulfur as -1. Check sulfur. -1 is not correct. That should be -2. So you need to also multiply this positive by 2 to get positive 4. So when I write out the words, it's going to be lead 4 sulfide. Last example, we have mercury and carbon. When I cross them up, it tells me that mercury is +1, carbon is -2. Check the carbon from the periodic table. -2 is incorrect. It should be -4. I know that I would have to multiply by 2 to get from 2 to 4. So I need to multiply by 2 here. And that gives me a charge of +2. So when I write it out, it's going to be mercury 2 carbide. Now, those were a lot of examples. If you have any questions as we're going along, please make sure you ask. If you're watching this Monday, Tuesday, you have a quiz. If you're not watching this Monday, or if you're watching, yeah,